G proteins are part of a family of GTP and GDP binding proteins. When bound to GTP, they are transiently active but switch themselves off by hydrolyzing the GTP to GDP, an inorganic phosphate.
G proteins include two subclasses, the small G proteins, such as RAS, and the more common heterotrimeric G proteins, which have an alpha, beta, and gamma subunit. Now, let's explore the signaling pathway of the heterotrimerics in more detail. As you will see, G proteins are vital to translating external signals from the environment into cellular responses throughout the body.
G proteins respond to a variety of extracellular signals, for example epinephrine, by coupling to a family of 7 transmembrane receptors called G protein coupled receptors. When activated by a ligand-bound G protein coupled receptor, G proteins transduce signals to effector proteins, which typically increase the concentration of a second messenger molecule. This activates further intracellular signaling cascades.
Anything that enhances the removal of bound GDP, allowing GTP to bind and activate G proteins, is called a guanosine nucleotide exchange factor, or known as GEF. An example of a GEF is the ligand-bound G protein coupled receptor.
Under normal physiological conditions, G protein activation is always self-limited by their intrinsic GTPase activity. After the G protein has been active for some time, it hydrolyzes GTP to GDP and shuts itself off. Proteins that speed GTPase-mediated G protein inactivation are called GTPase activating proteins, or GAPs. Regulators of G protein signaling, or RGS proteins, are a family of proteins that contain a conserved RGS domain which has GTPase accelerating activity.
These proteins were discovered in the 1990s thanks to the observations that GTPase activity of G proteins were dramatically decreased when they were isolated from cells. One of the people who discovered RGS proteins and has worked tirelessly to characterize these multifunctional proteins is Dr. David Sidorovsky. Why don't you take it from here, Dr. Sidorovsky?